Okay, a solution to a differential equation is any function that satisfies the differential equation. In other words, a function f is called the solution of a differential equation if the equation is satisfied when y equals f of x and its derivatives are substituted into the equation. So let's take a look at an example of this. So number 14, show that y equals e to the 5x is a solution to the differential equation y prime equals 5y. So we know that we need y prime here, so we'll find that. So this derivative is 5e to the 5x. So if I start with the one side here, the y prime side, I know y prime is equal to 5e to the 5x. That's equal to 5 times, I know that e to the 5x is equal to y. So that's equal to 5y, which is what I was asked to prove. So I've shown that that is a solution to the differential equation. All right, so number 15, I have 4 possible functions here, and I'm asked which of the following functions are solutions of the differential equation y double prime plus 2y prime plus y equals 0. Let's start with letter A. So e to the x is my y, and I'm going to need a y prime and a y double prime. So y prime is e to the x, and y double prime is also e to the x. That's pretty straightforward. And I'm going to test this possible solution out by plugging this in. So I'll start with y double prime plus 2y prime plus y. And instead of saying that that's equal to 0, what I'm going to do is I'm going to plug these in and I'm going to figure out what that's equal to. And I'm going to keep simplifying that until I see if that's equal to 0 or not equal to 0. Okay. So I don't want to say that this is equal to 0 and then plug stuff in and keep saying it's equal to 0 and see if I get a conflict there. That's not how we want to show that that's a solution. Okay, so what I'm going to do here is I'll plug my y double prime in, so I get e to the x, plus 2 times y prime, so I get 2e to the x, plus y, so e to the x. This gives me 4e to the x, which is not equal to 0. So no, this is not a solution. Okay. All right, so let's try another one. Let's try B. So this time y is equal to e to the negative x. So my y prime here is negative e to the negative x. My y double prime is positive e to the negative x. So same process, I'll start out with y double prime plus 2y prime plus y, and I'm going to replace those with what they're equal to. So I get e to the negative x plus 2 times negative e to the negative x, and then plus y, so plus e to the negative x. So this is equal to e to the negative x minus 2e to the negative x plus a positive e to the negative x. So I have 2e to the negative x minus a 2e to the negative x. That is equal to 0, which is what I'm hoping for. So yes, this is the solution. Okay, so this is the solution. All right, so I would like you to go ahead and pause the video and try these other two on your own. Okay, so go ahead and pause that, give that a try. All right, so these are a little harder derivatives, but I am confident in your ability to do them. So let's give these a try. So for y prime on letter C, I got, let's see, e to the negative x minus xe to the negative x. And for y double prime, I got xe to the negative x minus 2e to the negative x. And then I need to plug this into my y double prime plus 2y prime plus y. So I get xe to the negative x minus 2e to the negative x plus 2 times my y prime. So 2 times e to the negative x minus xe to the negative x plus xe to the negative x. And then let's simplify that. So I have an x e to the negative x minus a 2e to the negative x plus a 2e to the negative x minus a 2x e to the negative x plus an x e to the negative x. That is a lot of e to the negative x's. All right, let's see what we have. So I see these two here that are the same. They'll cancel. I have minus a 2x e to the negative x and plus 1 of each of those. So those will all go away. And I get 0, which is what I want. So this is the solution here. Okay, so I have 2 that are solutions so far. And then let's try this third one. So this is a little bit of a doozy on the derivatives. My y prime here is 2x e to the negative x minus x squared e to the negative x. And my y double prime, x squared e to the negative x minus 4x e to the negative x plus 2e to the negative x. And again, I'm going to substitute that into y double prime plus 2y prime plus y. So I get x squared e to the negative x minus 4x e to the negative x plus 2e to the negative x plus 2 times 2x e to the negative x minus x squared e to the negative x plus an x squared e to the negative x. Okay, and then I'm going to go ahead and distribute that to simplify, get rid of my parentheses. And maybe I'm going to go ahead and stack kind of like terms. So I have an x squared e to the negative x minus a 4x e to the negative x plus a 2e to the negative x. And this looks like I have a 4x e to the negative x. So I'll put that here. Line those up. And it looks like I have minus a 2x squared e to the negative x out of that. And then plus an x squared e to the negative x. Okay, so those are all my terms. So it looks like all my x squared guys cancel and all of the x e to the negative x's go away. But I'm left with this 2e to the negative x. So this is not equal to 0. So no, this is not a solution. All right, so there are just two solutions here, B and C.